All right, example, car's tires have a coefficient of friction of 0.5 with the roadway. The car skids to a stop from an initial speed of 40 meters per second. How far does the car skid before coming to rest? Draw a free body diagram, show a Newton's second law equation, and show a motion equation that led to your answer. Woo! This is a good one. All right. It's a good one because we're having to test a lot of what we have learned so far this year. Okay? Putting it all together. This is the whole idea with our free response questions on the AP exam. It's not going to be just forces. It could be forces in kinematics. It could be forces in circles. It could be a lot of different mixtures. Okay, so first things first. Draw a free body diagram. We're talking about forces, right? Because the mention of friction instantly tells my brain we're talking forces. And if we're talking forces, we need a free body diagram. So, here we go. Car's tires. Well, whatever the car's weight is, mass times its acceleration due to gravity, canceled out with a normal force. It's not floating, it's not sinking. Skids to a stop. So, the only force acting, for this to make more sense, I'm going to put the direction of my velocity. The only force acting is frictional force, slowing me down. We're starting with an initial speed and then we stop, right? Well, how long does it take us to come to a stop? We can use those constant acceleration equations, the kinematic equations, but for those we're going to need acceleration. Or at least a time, right? So before we can do that, let's get acceleration because we're talking forces, and forces and acceleration are the same thing. They are proportional to each other, not the same thing. But when you read forces, read acceleration. When you read acceleration, read forces. It's just going to help you determining what kind of strategies to use for a problem, especially like this problem, because it's so open. Like, where do you begin? Well, forces, free body diagram, we're talking forces, so we can get acceleration. If we get acceleration, is it constant acceleration? If it is constant acceleration, then we can use kinematic equations to determine the displacement. Back to solving. All right, so stuff that makes it go minus stuff that holds it back. We have a free body diagram, so we can get a Newton's second law equation, which is the next step in the process. So Newton's second law equation, stuff that makes it go, nothing minus what holds it back, frictional force, equals mass times acceleration. Oh no, we don't have mass. I think it'll be all right. So we have negative mu k, kinetic friction, times our normal force, equals mass times acceleration. Negative mu k, what's the equation for the normal force? Well, let's look at the free body diagram. These two things are equal, so Fn equals mg. They cancel each other out. If we added them up, if we did the stuff that makes it go minus stuff that holds it back, we could say Fn minus mg equals 0 because they cancel each other out. And we could add mg to each side. And we get Fn equals mg. There we go. Oh, here we go. mg equals m times a. Now we have mass on each side, so mass goes away. So we're good. We don't even need a mass. Now we can substitute in. We have mu k, which is 0.5. We know g to be 10 equals whatever our acceleration is. From this, we can see our acceleration is going to be, don't forget the negative 5 meters per second squared. Pretty cool, right? Right. Well, now, does it mention anything about our acceleration changing as it goes on or anything like that? No. So as long as it's a constant acceleration, then we can use those big equations. So we can guess information that's given to us. Well, we know acceleration equals -5 meters per second squared, and I'm going to leave off my units because it gets messy. Equals -5. My starting velocity equals 40 meters per second. My ending velocity, it's a secret, is 0. And what are we looking for? How far does the car go? So we're looking for delta x. What equation can we use? I don't see time on there, but I see displacement. How about the no time equation? Vf squared equals v naught squared. I'm not doing the shortcut, but I encourage you to if you have that memorized. 2a delta x. Now we'll substitute it in. Final velocity squared, 0 times 0. Initial velocity squared, 40 times 40 is 1600. Plus 2 times -5 times delta x. And then we get, let's go ahead and solve it. We get -1600 divided by -10 equals delta x. That, zeros go away. -160 divided by -1. X equals 160 meters. Don't forget your units. Circle your answer. And that's it. Any questions? Then ask.